just watching this video now. The other one was on a different language. And so far from what he explained, Quantile is a function that allows you to see the percentage. So it's pretty intuitive. It's basically exactly what the problem was asking for there. So if I have quantile of 95, that number, the result's gonna be which number is equivalent to 95% of the sample size. And if you want to remove the outliers, you would have a if statement or a Boolean statement like the previous challenge to select either bigger or smaller than the value
Could be either a data error or
that
it
the
could be a
function
legitimate
returns.
property, but these type of outliers will really hurt the performance of our model. So we need to tackle them. Okay, so let's first find out the min and max threshold by using the quantile. So here you can also supply an array in your quantile function and it will return you min and max threshold. Okay, and this I'm doing on price per square feet. I want to basically remove outliers based on price per square feet feature that I have in my dataset. My minimum threshold is 13,600 rupees per square feet. Maximum is 50,959 rupees per square feet. Now, if you're living again in Bangalore, you would know that if you're getting a home which has a value, price per square feet value of less than 1366 is most likely not true. It cannot be true. Bangalore is pretty expensive. So let's see what data points have very less value. So you can do something like this, where in your data frame you can say my price per square foot is less than minimal threshold, and give me all those data points. So I got all these data points. Here the price per square foot is ridiculously low. In Bangalore, I mean, come on, you can't get a home for 371 rupees per square feet. So these are most likely errors in our data set. Look at this guy here. 9-bedroom hall, kitchen, apartment, 42,000 square feet area, and you are getting, this is in lakh, you are getting in 1 crore 75 lakhs. This cannot be true. Okay, so these are clearly outliers. Now I used 1% and 99.9%. You can use different ones. Okay, so based on the situation, based on your intuition, you can use different thresholds. Also, if you have a domain knowledge, let's say you are working for makan.com or some property or real estate website, and if you have a talented business manager who comes to you and directly says, you know what, I know based on my knowledge of real estate in the city that the price per square foot should be restricted in this two range. Okay, then it's fine. Then you don't need to use Quantile. But as I mentioned before, many times you don't have that domain knowledge. Many times features are complex. That's when Quantile can be really useful. Okay, now let's look at our data point, which has, okay, price per square foot is greater than max threshold. Okay, now we are looking at the data sample on the higher end. Here, check this property. The price per square foot is ridiculously high. All these are like very, very high prices. Now, I'm not saying these are data errors. Maybe some of them are valid, but if you keep these in your model, while you're building model, if you keep these data points, they are really going to hurt the performance. So to remove these outliers, what you can do is you can create a new data frame. All right, how do you create a new data frame? Like this. So here what I did is remove anything whose price per square foot is less than max threshold. Yeah, so basically keep anything that is that whose price is less than max threshold and greater than min threshold. So this will automatically remove your outliers. And now my new data frame, which is df2, has 13,172 rows. Initially it was 13,200. So we removed few outliers here. And if you do df2.sample, by the way, you can use sample just to randomly sample some rows from your data frame. And if you print 10 random rows, they show these values. And you see that these values look pretty decent. That's all I had for this tutorial. Now, the most interesting part of this tutorial is an exercise. You have to use Airbnb New York dataset from Kaggle. So if you right click on this link, you will find this dataset here on Kaggle, and you can click on this button to download the dataset. If you don't want to do that, then you can actually go to my GitHub, and on my GitHub, under this outlier, there is an exercise folder. In that exercise folder, you'll find the CSV file. Now, this IPython notebook is actually a solution for the problem. So don't look at the solution until you have tried it out yourself. So what you have to do is you have to analyze this data set and remove the outliers based on the price per night.
Right, let's start this section here. So install elements. That's the first one. I guess I just need to put this command on the console and it's gonna install. I'm not gonna lie, I just wanna finish this as fast as possible because I'm really curious to see the AI section they have. Machine learning, which is the last one. From the basic videos I watched about machine learning and deep learning, it doesn't seem too complex, but it's probably really difficult to actually code and think about the problem. Okay, so here should be the version instead, the end there. I'm just gonna Google this. It's easier. I think I'm gonna close this. Probably not gonna read now. Yeah, install elements. Oh, there's a typo there. So it looks like it worked. Install element, then required. You can install a specific version of package. Oh, actually, no, so it's not passing. Maybe the version is wrong. Yeah, the version is probably off. Hopefully it works now. What the fuck? What's wrong with this? don't remember what was the symbol true. I remember there. Oh, remember now. It's this one. The other one. Don't remember the differences exactly. I know it's for the versions, but oh, I know what I'm doing wrong. I'm sending the wrong link. I got used to the other challenges. And it's still not working. Nice. Okay. Hackers can exploit known vulnerabilities in Express node if they see that your site is powered by Express. It's sent in every request coming from Express by default. Use the helmet.hide powered by middleware to remove the export by header. Oh, it's a middleware. But they don't explain it. Where should I put this middleware? I think from what I saw in the websites, I should require the helmet here. Yeah, helmet. Maybe just app.use.
So in this second challenge, what we're going to do is get rid of the powered by header that happens when we're making a request to an Express app. And I'll show you what this is. So if I just copy this live app link to start off with, and I just submit it, and free code camp will then make a request to our Express app, and then Express app will return a response, which is how they do the testing. So if we run this, and in the Developer Tools Network tab, we can see that this app info right here, if you look at the URL, it goes to my app. And if I just click on that, and then look at the headers, in the response header, we have this header called X powered by, and that says Express right here. So Express basically will add in this header when it sends a response back out to the client. And this is useful if you want to know what platform is powering the app, but it can also be very dangerous because the fact that anyone sending a request to this app can know that it's powered by Express, and then they can find potential exploits to do with Express apps that you can probably see on like GitHub issues or something. And they can try and use that exploits to hack your app. So you want to make sure that we get rid of this X powered by field right here, and that's why we'll use a middleware from Helmet called hide powered by. And a very, very important thing that you have to do to make this challenge pass is because they've changed the methods again. So you want to make sure we need to downgrade our version of Helmet, because right now it's 3.2, 3.3, but we need to downgrade it to 2.3.0 if we want to get this test to pass. So what you want to do is in the terminal, which is in glitch, and it's in tools and then terminal right here, you want to first uninstall the current version of Helmet by running npm uninstall helmet like this, and that will remove helmet that's currently installed. And it's best to uninstall it always before you change the versions. Then you want to run npm install, and you want to do helmet, but you want to put at 2.3.0. So we're downgrading from 3.2, 3.3 changes from our terminal to in 3.0. Perfect. So what we want to do is we want to mount this helmet hide powered by function, which is a middleware for all routes. And remember, in Express app, to mount something for all routes, you'd say app or use like this. And inside it, we can call the helmet hide powered by method. So
Oh, maybe I need to take this off. But yeah, it doesn't feel like it's the right way to do it.
helmet.hide powered by like this. And you don't have to give any arguments here, but optionally what you can also do is just give an object inside this, and you can say set to like this, and this will basically spoof it by setting this to something like PHP 4.2.0 rather than Express. And this can be useful to throw people off if they're trying to find out how to exploit your app, so they'll think it's a PHP app.
So maybe it's the version, the reason why it's not working. Because apparently I did it the correct way. Oh, now it works. Weird. Maybe I typed something wrong there. Your page could be put in a frame or iframe without your consent. This can result in click jacking attacks, among other things. Click jacking is a technique of tricking a user into interacting with a page different from what the user thinks it is. This can be obtained executing our page in a malicious context by means of iframing. That context, a hacker can put a hidden layer over a page. Hidden buttons can be used to run bad scripts. This middleware sets the X-frame options header. It restricts who can put your site in a frame. There's three modes: deny, same origin, and allow from. You don't need our app to be framed. Use helmet frame guard, passing with the configuration object action deny. So it's the same thing as before, but with different function. And then I pass the object inside to deny the frame, I think. Well, now it's not working, but maybe it passes. Cross-site scripting, XSS, is a frequent type of attack where malicious scripts are injected into vulnerable pages with the purpose of stealing sensitive data like session cookies or passwords. The basic rule to lower the risk of an XSS attack is simple: never trust users' input. As a developer, you should always sanitize all the input coming from the outside. This includes data coming from forms, get query URLs, and even from post bodies. Sanitizing means that you should find and encode the characters that may be dangerous. Other browsers can help mitigating the risk by adopting better software strategies. Often these are configurable via HTTP headers. The protection this protection HTTP header is a basic protection. The browser detects a potential injected script using a heuristic filter. If the header is enabled, the browser changes the script code, neutralizing it. It still has limited support. So this sanitizes the input from the user. I think Helmet is a framework for, not sure if it's a framework or library for protection. And apparently that's what they recommend. Free code on Free Code Camp. As a reminder, this project is being built upon your finally started project. Yeah. Use Helmet no sniff method on your server. Browsers can use content or meme sniffing to override response content type. Browsers can use content or meme because and process the data is an implicit content type. While this can be convenient in some scenarios, it can also lead to some dangerous attacks. This middleware sets the X content type options header to no sniff, instructing the browser to not bypass the provided content type. Some web applications will serve untrusted HTML for download. Some versions of Internet Explorer by default open those HTML files in the context of your site. This means that an untrusted HTML page could start doing bad things in the context of your pages. This middleware sets the Xdownload options header to none open. This will prevent IE users from executing downloads in the trusted site's context. Use helmet no open method on your server. HTTP strict transport security is a web security policy which helps to protect websites against protocol downgrade attacks and cookie hijacking. Your website can be accessed via HTTPS. You can ask users' browsers to avoid using secure HTTP. By setting the header strict transport security, you tell their browsers to use HTTPS for the future requests in a specified amount of time. This will work for the requests coming after the initial request. Configure helmet.hsts. Choose HTTPS for the next 90 days. Pass the config object max age time in seconds force true. You can create a variable 90 days in seconds. Choose to use for the time in seconds. I don't understand the second part here. I think what I need to do is put this like this again. Then I put this object inside of the request. But then I'm not sure if I should create a variable here. Oh, actually, this. I'm not sure if that's what I'm supposed to do. Yeah, I think that's what I'm supposed to do. So this is the time in seconds that this function will be true, which is 90 days here. This is 90 days in seconds. Replit already has HSTS enabled. To override its settings, you need to set the field force to true in the config object. We will intercept and restore the replit header after inspecting it for testing. Configuring HTTPS on a custom website requires the acquisition of a domain, an SSL TSL certificate. Cool. To improve performance, most browsers prefetch DNS records for the links in a page. That way, the destination IP is already known when the user clicks on the link. This may lead to overuse of the DNS service. If you own a big website visited by millions of people, privacy issues, one eavesdropper could infer that you are on a certain page, or page statistics alteration. Some links may appear visited even if they are not. If you have high security needs, you can disable DNS prefetching at the cost of performance penalty. Use Helmet DNS prefetch control on your server. If you're releasing an update for your website and you want the users to always download the newer version, you can try to disable caching on client's browser. You can try to disable caching on clients. It can be useful in development too. Caching has performance benefits, which you will lose, so only use this option when there's a real need. So this is stops caching, I think, which stops the website from storing information about the user, probably. So it's probably not used very often, I would guess. CSP works by defining an allowed list of content sources which are trusted and can configure them for each kind of resource a web page may need. Scripts, style sheet, fonts. There are multiple directives available so a website owner can have a granular control. See HTML5 rocks, keys, DN for more details. Unfortunately, CSP is unsupported by older browser, but default directives are wide open, so it's important to set the default source directives fallback. Common supports both default source and default source naming styles. The fallback applies for most of the unspecified directives. This exercise use Helmet content security policy configured by editing a directives object in a directives object in the object. Set the default source to self. So it's double quotes here. The list of allowed sources must be an array. In order to trust only your website address by default. So this putting self here allows only your website as default. Also set the script source directive so that you only allow scripts to be downloaded from your website and from the domain trustedcdn.com. In the self keyword, the single quotes are a part of the keyword itself, so it needs to be enclosed in double quotes to be working. So I need to put this here, then I need to put an object. Set the script source directive. So that you only allow scripts to be downloaded from your website. So I'm not exactly sure what this is supposed to mean. I think it means this, but I don't know. I'm gonna set two values for this. I think an object inside of the object doesn't work. Maybe we should put an array as well. Maybe that's how it works. So obviously that's not working. Let's try like this. Okay, I'm just gonna search this one.
So now we're going to look at a content security policy, and this basically ensures that the resources to our site are only delivered from certain sources that we declare as trusted. So a content security policy is basically like a header or a meta tag, I guess, and it looks something like this. So this is one, for example, and what this says is that JavaScript can only be loaded from these two places, and style sheets can only be loaded from these places. So it basically says the type of resource and then where they can be loaded from. And there's a resource for this on the official content security policy website, and it has a list of all the sources. So this default source basically means for if we don't declare a specific type of source, everything will be only available to be loaded from the places that we set here, unless they've been specified otherwise. Script is for where scripts can be loaded from. Style is for where style sheets can be loaded from. We have images, fonts, objects, and a bunch of stuff right here. Then we also have a resource for the source list. And what you can do is you can have star, which means it allows anything. We have none, which is it doesn't allow from anywhere. Self, which means it's allowed from its own domain. And then we can use stuff like star.example.com. So this means any subdomain from that website. And you can use like HTTPS, which means any secure site and so on. So there's a bunch of ways that we can do this. Another Another thing to note is down here it says CSP is unsupported by all the browsers. I should say all the browsers, but okay. We can see that Internet Explorer, our good outdated friend, doesn't actually support it. So it only works for new browsers, but most people are using new browsers, so this should be okay. And the way we can set a content security policy header is you can use a Helmet middleware called CSP. And what you can do is inside it, you can give this directives object, and you can declare what each of these have to be. So you can set what the default sources are. Then you can set where scripts can be loaded from, where you can set objects can be loaded from, and so on and so on. And inside all of these, you just give this array here with a string inside it, and it has the sources right here, like this. So let's go ahead and do that now. So again, for this, I'm just going to double check this. Yeah, we should be using Helmet version 2.3.0. So make sure that you have that, otherwise these tests won't pass. So in myapp.js, we want to just go down here, and we want to call the app.use here to mount this for all sources, or all roots, I guess. And we want to say helmet.csp like this. And we want to call this method. And remember that inside this, you give this options object right here. So that's the first layer. There's a lot of objects embedding in this, so I'll try and keep this clear as possible. And inside this, you give this entry called directives like this. And you want to set this to another object inside it. And what I'm going to do is
So he uses CSP, and here's content security policy. Or I need to put it inside of directives. Yeah, it's the same way, pretty much. Let's see if this works.
open up this object because it's getting a bit crowded now. So inside the directives objects, you add entries for each of the different types, for each of the different, I forgot what they're called, directives. So you want to set the ones for the default scripts and so on. And in this one,
Okay. App.useHelmet will automatically include all the middleware introduced above, except no cache and content security policy. But this can be enabled if necessary. You can also disable or configure any other middleware individually using a configuration object. So it's pretty much the same thing, but all at once. Introduce each middleware separately for teaching purposes and for ease of testing. Using the parent helmet middleware is easy to implement in a real project. No tests, it's a descriptive challenge. Decrypt hashes are very secure. A hash is basically a fingerprint of the original data. To further complicate this process and make it more secure, you can also salt your hash. Salting your hash involves adding random data to the original data before the hashing process, which makes it even harder to crack the hash. Which does have a structure. The first small bit of data is defining what kind of hash algorithm was used. The next portion finds the cost. Cost about how much power it takes to compute the hash. It is on a logarithmic logarithmic scale of true cost, true to the power of cost, and determines how many times the data is put through the hashing algorithm. At cost 10, you're able to hash 10 passwords a second on an average computer. However, at the cost of 15, it takes 3 seconds per hash. And to take it further, at the cost of 31, you would takes multiple days to complete a hash. A cost of 12 is considered very secure at this time. Less portion of your hash looks like one large string of numbers, periods, and letters, but it is actually two separate pieces of information. The first 22 characters in the salt is the salt in the plain text, and the rest is the hashed password. Should begin using Decrypt as this dependency in your project and require it as Decrypt in your server. Add all your code for the lessons in the server.js file between the code we have started you off with. Also, this is for the server file. So it's Decrypt. So they don't talk about version.
Okay, so now that we are able to create users inside our database, so let's hash their passwords before saving them to our database. So let's go to our application here, and for this I'm going to use a package called Decrypt. So firstly, let's install that package. So npm install save Decrypt, and this package uses the bluefish algorithm to encrypt passwords. So now let's start this application so that the application is already started. And now what we can do, we can use this Decrypt package to generate a hash password here inside the register of encrypt passwords. So now, and this package uses the bluefish algorithm. Install that package. So npm install save Decrypt, and this
See if this works. Let's try again. So I think it worked. Now I just have to require it here. Probably. So it's probably like this. That's weird. Required as Decrypt. So why it's not working?
To look at hashing out passwords using Decrypt, and you should know that you can never store plain text passwords, and you should always hash them using an algorithm. And to do this, we're going to be working on a completely new project, separate from the Helmet one. So what you want to do is just open the GitHub link and then just copy the code with the clone link right there, and you just want to click new project here, import from GitHub, and just paste it into there, and that will start that will start downloading the project for us. And the tool that we're going to be using to do our hashing is an npm package called Decrypt. So once I've installed Decrypt, what we can do is we have a bunch of functions where we can give a plain text input and it will create a hash for us. And what you do is, let's say how you have this input right here, and then you have this variable called soltrons, and that's basically how many times you're going to apply the algorithm. So if it was 1, for example, it applied once. If it was 2, what it would do is it would hash it, and then it would run the algorithm again with the hash. And this one would do it 8 times. And what you get back is, let's run this hash. So you get something back like this. And the first 2 characters right here, this 2b thing, is a
I don't understand what's wrong with this. Why it's saying that's not working? The installation part seems to be passing the test. Should be a dependency. Maybe it's the version. Maybe I need to require it before everything.
type of algorithm that's being used for the hashing. So I think this is B, which is the hash sync one, but we'll be looking at the 2 algorithms soon. Then this right here is the cost, or the number of soltrons. So that's the number of times you've applied the algorithm. And then the first like 22 characters or so of this is the salt. And the salt is basically a random piece of data that they generated here. And then they put that together with our plain text input, and then use that and then hash that. So basically a random piece of data, which is the salt right here, is also added. And then the salt, which is the first 2 characters of this, and the plain text input gets smushed together, and then like the hashing algorithm is run. And I don't know the mathematical detail about how this works, but it is a one-way function. And the remaining characters from this after the first 22 characters from here is the actual hash itself. So that's the salt, the random salt, and the plain text input smushed together into the hashing algorithm. And the important thing is you can't basically get back the original input from this, but what you can do is you can test an original input with this to see if they match. And so hashing is a one-way algorithm, and that's the most important part of this. And this is why it's safe to store our passwords like this, because the only way to get our original password back is through trial and error. So the first thing you want to do is install Decrypt, and what you want to do is just open the glitch terminal in a new page. And what we're going to be doing is installing Decrypt, and you can see that it's not installed right here. And the package name for Decrypt is just Decrypt, so you just want to do npm install Decrypt like this. And again, in the next 2 videos or so, we're going to be looking at 2 different ways to create hashes and then to check passwords against them. So right now in this one, all we're doing is installing Decrypt. And in server.js, what you also want to do is after these require statements, you want to just require Decrypt as Decrypt. So you just say let Decrypt equals require, and remember the package name is just Decrypt like this. And by the way, once this
So weird.
finish installing, you want to make sure you run the refresh command to restart our app to make sure that Bcrypt has been applied. And if we look at package.json now, you should see that Bcrypt has been installed. So in this challenge, all you have to do is install Bcrypt and required. And what you can do then is just click share and then live app, and just copy the live app link and then submit it here. And what you'll see is that the tests have passed and we've installed Bcrypt. And in the next challenges, we'll be looking at actually hashing and comparing passwords.
Maybe we need to do this refresh thing. What's going on? Let me try to. Do not edit this file. The verification process may break. So maybe I should require it on the my app.js instead. Oh, maybe it's const. Maybe that's what's wrong. Which is weird because all the other ones are with var instead of const. Well, didn't work as well. I guess it's just free code camp that is bugged. Or maybe replit.
All right, guys, so we are doing the Information Security and Quality Assurance certification on Free Code Camp. This one's going to be diving deep into, not diving deeper into Node and Express. It's also going to be covering testing with Chai. Unit testing is one of the things that I'm quite strict about, and I think testing will make you a significantly better developer. And then you have things like information security with Helmet.js, which is a package to help you with it, and that's what we're going to get started with. What we'll be using is Glitch, which is a little online code platform that they're going to do for this. At least this one, I'm not sure about the others. might I take a moment to recommend our long-term sponsor. Long-term, as in we've been working together for almost 3 years now, which is pretty crazy. And a lot of changes have happened at Dev Mountain. They've changed a couple locations in the past to now they're in the Lehigh area. They're also in Dallas and Phoenix. But if you're interested in considering a coding bootcamp, might I recommend DevMountain.com. They have programs in full-stack JavaScript, iOS development, QA, UI, UX. You can find out more information at DevMountain.com. And what we can do is just simply open up a new file like so. It's going to create your starter project, which you'll have like this, and we can get going. So the very first step, and we're going to be jumping back between the step here and what's going on. And so the very first step is to install our package JSON. So we can go to here to dependencies. Now, I don't think I tried this earlier to do it in the console itself, and I don't think we can do it. But let's see, maybe we can now. Where is the console? I had it up at one point. I don't want a full page console, but let's see if npm's installed. I was playing around with this earlier and I didn't see it, but maybe. Okay, so if we do npm install helmet, will it do it? Failed to parse JSON. All right, let's see if we do that now. All right, so did it add it? If we go to my app, back to package JSON, add package. No, didn't add it. All right, we'll just do this. Helmet. Do this. All right, helmet. There you go. Cool. All right, so I think we are good to go. It's formatted. Look at that. That's pretty. I really do like this. And let's go ahead and copy this and see if we are good to go here. And we go ahead and say, I've completed this challenge. It's going to run our test unexpected token in JSON in position 0. What does that mean? Console. Maybe that's not what we're supposed to. Let's try it again. So. Let's do this.
Don't understand what's wrong here.
Maybe this is what needs a live out. There we go. Needs a live out. Okay, cool. Submit and go on. Maybe later.
It should be
All right,
fine.
so information security with Helmet.js hides potentially dangerous information by using helmet.hide powered by. Hackers can exploit known vulnerabilities. What's exercise powered by express powered by. Helmet hide powered by middleware remove X powered. You can also explicitly say this. So
Maybe it's just
it looks like they want us to simply have this in our code.
Maybe it's just a different wraplet. And that's probably the problem here. And you started. No, that's the problem. So now hopefully it works. Nice. So I'm gonna close this one. A session is designed to be computationally intensive. It is a requirement that you do so asynchronously on your server as to avoid blocking incoming connections while you hash. All I have to do to hash a password asynchronous is call. Okay. So we're calling Decrypt with hash. These arguments and then the function. Add this hashing function to your server. We've already defined the variables used in the function. Where you choose and log into the console for GC. At this point, you would normally save the hash to your database. Now, when you need to figure out if new input is the same data as the hash, you would just use the compare function. So this gets the hash, and this would compare them, compare the hash with the input. So this you would get the input and save to the database. So later on you can compare. Add this into your existing hash function. Oh, it's inside the hash function. Since you need to wait for the hash to complete before calling the compare function. After log the completed hash and log rest to the console within the compare. You should see in the console hash, then true is printed. So I guess this goes inside the other one, but I'm not quite sure. You should see in the console hash, then true is printed. If you change my plaintext password in the compare function to some other plaintext password, then it should say false. Yeah, I'm not really sure what I'm supposed to do. Yeah. So I guess this is just they're just explaining first you get the hash and it's an asynchronous call. So if you want to compare, it has to be inside the function that gets the hash. Hashing synchronously is just as easy to do, but can cause lag if using it server side. With a high cost or with hashing done very often. Hashing with this method is as easy as calling. Add this method of hashing to your code and then log the result to the console. Again, the variables used are already defined in the server. You may notice even though you are hashing the same password as in this async function, the result in the console is different. This is due to the salt being randomly generated each time as seen by the first 22 characters in the third string of the hash. Now to compare password input with the new sync hash, you would use the compare sync method. So it's pretty much the same thing, but synchronously. And because it's synchronously, you don't need to do one inside of the other. Add the function in and log the results to the console. I don't think console logging is required to pass. Nice. I'll be right back. Now I think is the videos done. think I can close this. Yeah, the video's done, the projects. I'm gonna look at the solutions for the projects, just being honest. And the machine learning, I think, is also a bunch of videos. And the machine learning, I think I'm gonna spend time trying to do the challenges. Because it's more interesting to me. I'll be right back. Right, I'm back.
Hey guys, Hackersploit here. Welcome to Python for Ethical Hacking. So I decided that I would go through the most important things that you need to know as a penetration tester with Python. Now, in this series, we're going to be what we're going to be focusing on are the most important things that a penetration tester must know, and are of course essential to know, especially when you're talking about Python. So we'll be looking at network sockets. All right, so that means creating a TCP client, TCP servers, and UDP clients and servers. All right, so those are probably the most important things that you should know. We'll then move to finally building a Netcat alternative, which is usually the exercise that I really recommend people to do, is to build a Netcat alternative, or not really a clone, add functionality of your own. So we'll be focusing on that. But in the middle, I'll be explaining about sockets and networking with Python. And the penetration testing environment that I'm going to be using for this series is Kali Linux. Okay, you can work on any other distribution. It all depends on you. I've been using Visual Studio Code for a long time now. Now, if you don't know what Visual Studio Code is, let me just tell you something. You need to know what it is, because I've been using it now for web development, for scripts, PHP, and obviously now Python. I've tried it with Python and it works awesome. And the best part is it's lightweight and you can install it extremely easily on Windows and Linux. That's why you can see I have it running here on Kali Linux. And it works on Debian, Ubuntu, Red Hat, Fedora, and obviously Windows if you're running that. So just download it. It's about 50 megabytes. And for Kali Linux, make sure you download the Debian package. So you can see I have the Debian package here. And to get it installed, I'm going to open up my terminal here. And sorry about that, I've just started a new virtual machine with Kali. So my font might be a bit small. So what I can do here is, in fact, I'm just going to show you how to get it installed. I'll probably zoom this in when I'm editing the video. All right, so if I list the files in here, you can see that I've already given it permissions to be executed. So you can use the chmod or the chmod permissions to make it executable. And then finally, you can use the dpkg, the Debian package manager. So dpkg and you use the name of the Debian package, and you just hit enter and it's going to install it for you. So I already have it installed. And once you have it installed, you now need to install the Python extension, which you can find here in the extension section. And it's going to be the first one, or if you don't get it, just search for Python. Now, during the course, I'll be telling you to install the other ones that I like, that are not really specific for Python, but will make your development environment really better. So just click on Python. It is developed by Microsoft. In this video, we're going to be looking at how to create a TCP server. Now, of course, I mentioned that we would be starting off with creating sockets, but it came to my understanding that if you really want to understand how sockets work with Python, then you need to implement them into a simple example. And of course, this might not be very simple, but creating a TCP server and client, which is what we're going to be doing. But in this video, we'll be focusing on creating the server. In the next video, we'll be looking at creating the client, and then I'll show you that they actually do communicate with each other. All right, so we'll be completing the connection or the communication. Now, before we get started, I just want to say that I am using Windows, but nonetheless, I'm still using Visual Studio Code. I've installed the Python extension by Microsoft, and we're ready to go. Now, as I said, I wanted to start off with sockets. Now, the problem, as I said, with sockets is they're a very important thing when it comes down to penetration testing with Python, and that's because they initialize connections and they allow the sending of and receiving of data. So, if you might be a little bit confused or you have no idea of what a socket is, don't worry. I'm going to explain them to you in both a technical and a simple definition. So, in terms of technicality, a socket is an internal endpoint for sending and receiving data. All right. Now, if I was to explain it simply, we can use the analogy after which it was named. A socket is like an outlet. All right. That essentially gives you connection of power. That gives you connection of power from your transformer, from the grid, to the transformer, to your house, and then you can finally use the power. The only thing about that analogy is that you cannot send power through the socket, you only receive it. The thing about a network socket is it allows you to send and receive data, all right? So it's an internal endpoint, which means it works locally. So, you know, we've talked about ports and how they work, so that's how it works, all right? Now, the socket module or the socket library in the Python standard library is a fantastic module and allows you to implement this connection, or allows you to implement sockets using different protocols. So, for example, we are going to be looking at TCP, but we also have UDP, which is awesome. Okay, so when we talk about sockets in Python, we have the socket module. Now, the socket module, for you to utilize it, is you need to import it, and then finally to use it in your code, you need to call the socket function, which is denoted by socket.socket, as you probably know. But if you don't know, we'll be looking at it as we create the TCP server. Okay, so we are going to be importing the socket module, and then we need to use the socket function that is available in the socket module, and that also has a very specific syntax, a syntax that not many people understand, and that's what I want to clear up here. The thing about Python is we need to create an object. The object will then call the socket function. Now, in that socket function, you have parameters that you need to specify. For example, we have the socket family. The socket family is usually specified in the form of AF-INET, which you've heard of, and I'll explain what that is. And then you have your socket type, which is specified by sock stream or sock dgram to specify the two of the most important ones. And those are the two parameters that you need to specify, okay? Especially with Python 3. So let me explain what AF-INET is used for in terms of socket family. So when you're specifying socket family, you usually see that we use socket.sock, sock stream or sock, or the AF-INET. Now, we start off with AF-INET. AF-INET is used to specify the protocol that will be used for communication. You might be wondering, well, what are you talking about? We're using TCP or UDP. What other protocols are you talking about? The protocol I'm talking about is either IPv4 or IPv6. As you know, the transmission control protocol has different ways of routing data through a network. So we'll be using IPv4, which is denoted by AF-INET. We then have the socket type, which is denoted by either sock stream or sock dgram. Now, these depend on the type of connections that you'll be using in terms of protocols. So, for example, sock stream will mean you're specifying TCP as your, will mean you're specifying connection-oriented protocols like TCP. What do I mean by this? TCP is a connection-oriented protocol that essentially involves you performing a three-way handshake to initialize connection with a server and a client. Okay, so the other, connectionless protocols like UDP, you would use the socket type of sock dgram. Okay. So I hope I'm not confusing here. We'll be looking at how this applies practically in a few seconds. All right, so let's move on now to the functions or the methods that we will be using. So some of the most common ones we'll be using are the bind method, which will allow us to bind the host and the port to a socket. We then have the listen function or method that will allow us to start the TCP listener. We have the accept method, which will allow us to accept the incoming TCP client information. We then have the most common ones, which you probably know, but if you don't worry. We then have the send function, which allows us to send a TCP message or a message over TCP. We then have the send. We then have the receive method that allows us to receive TCP messages or a message over TCP. And then we have the close method, which allows us to close the socket. And therefore ending the connection, as you would have probably guessed. All right, so we'll be using all of those methods, and I'll be explaining them as we move on. So we'll be creating a simple TCP server. So let's get started with that. So I'm using Visual Studio Code. I'm going to create a new file, and I'm going to save this on my desktop right here, and I'm going to call it server.py. So we are using Python 3. So if you're running this on Linux, we specify the working directory, which if you're on Linux is user bin, and then if you're using Python 2, you would specify the environment, which is Python 2, but in this case we're using Python 3. All right, so that's what you do. Now this doesn't matter on Windows. It'll automatically use Python 3 because that's what I have installed. So now we need to import the socket module. All right, so socket. And as you can see, we've imported it. Really simple. I love Python. Now we need to create the object, the socket object. Now many people like using the S. The thing about using the S is it kind of confuses you as to what's going on. So I'm going to call this server socket. All right. You can call it server socket object if you want to, but I'm going to keep it simple. That's the object. So now we're calling the socket function. So we'll say socket dot socket like so, socket dot socket. And now in here we would specify like so. You can open the brackets if you want. Others like doing it in the same line. Now we need to specify the socket function and the socket type, the socket family and the socket type. Sorry, not the function. We've already specified the socket function. So now we would say socket.af inet. That means we're using IPv4, and then we need to specify the type. All right. So socket. Sorry about that. I got a little bit confused there. My keyboard is not even in front of me. So socket.sockstream. All right. That essentially tells us what type of communication we're going to be doing, through what protocol, TCP or UDP. In this case, we're using a connection-based protocol. Again, in this case, TCP. So now that we've specified that, we now need to create another object that will store we need to essentially store the host name, which we'll use the get host name. We'll be using the get host name function from. That's another function that I didn't specify earlier, but I'll explain what it does. So we'll say host, we're getting the host information, so we're getting the host name, so socket.hostname, and again, actually it's not host name, it's get host name. The thing about this is a function that will get the host name, so it'll get the address and any other information that we specify. I'll get to this in a second. We then need to specify the port that we'll be listening on. Now this you can specify to whatever you want. I'm going to set mine on, if you're on Windows, it's going to ask you for your firewall permissions to allow that, to allow you to listen on that port. So make sure you accept it with administrator privileges. So I'm going to set the port to something like 444. I usually like that. I don't really know, and a lot of you guys have pointed that out. All right, so now we need to use the get, we've got the host name. We now need to bind the object. We need to bind the values that we got back, which are the host and port, but we need to bind them to the object that we created, which is the server socket. So right, so we're going to say server socket, and now we need to bind it. So we're going to say dot bind, and this essentially means we're going to be binding the addresses that we got, which is the host and the port to a socket. And the socket we've already specified as the socket object which we've created. All right, so bind, and what are we binding in here? We're binding the host and the port. All right, so we've specified the host, as you can see here, and we've got the port right there. So that's working out quite well. Everything makes sense. Now we need to listen for TCP. We need to set up a TCP listener, listen for TCP connections from the client. So we need to set up a listener. So server socket.listen. All right, and of course you can add comments to your code if you want to. Once I'll upload this to GitHub, by the way, the link will be in the description. It should have documentation as to what's going on. All right, so we need to listen, and now in the parameters here, we can specify how many connections we can listen to at a time. So a lot of people actually forget this, and they try and connect from various computers, whilst one has already initialized the connection. So if you want to connect to this server from many computers, you can specify the amount. So I can specify 3, for example, and you can specify as many as you want there. All right, so now that we've specified the listener and how many connections, how many requests we should have, or how many requests to allow at a given time, we can now use a while loop here. So we're going to say while, and we could have added this into a loop at the beginning, but I was going through this and I decided that we can specify an option here. While all of this is true, all right, when we get all the connection information, we can then say establish the connection. All right, so we create another object here. So we say client socket, which we'll be using in the next video, client socket, and the address. All right, we can specify also another one, address. This is going to be equal to the server socket, which is the server socket object. And then remember I said we're going to be using the server socket methods or functions like the accept function, which will allow the TCP connection. So we'll say server socket dot accept. All right, and this will accept the TCP information coming from the client. All right, now we can print in some data here. So we'll say print, and we can say, for example, we can notify the server that we've gotten a connection. So we've said received connection from, and then we can use concatenation. So receive connection from, we can say, let's see, receive connection from we got the address, which is, we need to convert it into a string. So we can concatenate this and say, sorry about that. We got the string and we're going to convert that is the address, right? We're going to convert it into a string because the client socket information will still be in terms of the host. The address needs to be saved as well. All right, so converted that into a string. Awesome. Now we need to create a message, and we can say message is equal to, let's see, we can say thank you for connecting to the server, or we can also add something a little welcomey, so hello, or something really stupid like that. I'm not really thinking this through in terms of the amount of information I'm trying to add here. We can then also start concatenation here, and we can then specify, let's see, do we need to move to the next line? Yes. So we would specify now that we want to move back, we want to go to the next line, so rn. All right, and sorry about that. My keyboard is so far away from me, it's unbelievable at this point. All right, so we specify that now we can now decide whether we want to encode the message in terms of types of encoding, but I'm not going to do that because I don't want to overcomplicate you guys. So now we can close the socket that we created, which was with the client socket, which again is not related to the server socket. So we can say client socket, and we can say dot close. All right, so this is going to close the connection while any of this information is true. All right, so that is how to create a TCP server in Python 3. Now, of course, I would like to think that I've explained everything correctly, but if you have queries as to any for any part of this, or you have any questions or suggestions, just let me know. But if you have any problems, always just let me know in the comment section, or if you want to contact me privately, contact me through the website. Now this will be on GitHub, and don't worry, I'll add the documentation so you can understand what's going on. So let's just go over what we've done. So we've imported the socket module from the Python standard library. We then created a server socket object, which then called the socket function, and we specified the socket type and the socket family. The socket family and the socket type. We then we then give the socket.get by hostname. We give that value to host, and we also specify the value for port, which was 444. You can specify whatever you want. The great thing about Python is you don't have to specify data types, which is awesome, right? We then had to use this. We used the server socket object, and we binded that. We essentially binded the address, which is host and port, to the socket. We then set up a TCP listener here, which would listen for connections up to a maximum of 3. And then while all of this is true, you could see we created 2 more. We said client socket and the address are going to be equal to server socket.accept. That's going to be the information that we accepted from the client. And then we're going to print receive connection from, and we specify that we want to convert it into a string. We want to convert the address into a string. And then the message we specified was going to be hello, thank you for connecting to the server. And we closed the socket. Again, I know a lot of you might have noticed a mistake I made here, and that is I did not send any data back. And you might be wondering to yourself, well, what exactly happened here? What do you mean you haven't sent anything? You haven't sent anything. Well, you can see that we gave the message a value, but we didn't actually send it. And you remember I talked about the send function, all right? So we need to specify that we are sending this information. So we'll say, before we close it, we want to let the client know that they've successfully connected to the server, all right? So we'll say client socket, and that's going to be, we'll use the send function, and in here we specify the value, which is, again, we give the value of message there, and we even be using message. So this is what will be sent to the client once they connect to the server. Awesome. So that was a bit of an example as to what I was saying. It gets really complicated when you're initializing the connection, and we'll also be looking at receiving data back, which is also very important. So hopefully this was a good introduction into using sockets. Again, I said I don't expect you to understand everything if you're a beginner, and I would expect you to have understood Python 3, at least the basics till now, but I'll be covering the advanced stuff. As you can see, it's not really beautiful code. I mean, it's quite ugly, so, and I really believe in the Zen of Python, so I'll improve this up and I'll upload it to GitHub.
I think I roughly understand what he's saying. Probably will forget most of it, but at least I understood.
In this video, we're going to be looking at creating the TCP client. So in the previous video, we looked at how to create the TCP server, but now it's time to move on to that end, and finally we'll initialize the connection and see how data is being transferred, for the purpose or for the sake of learning about sockets. The first thing that many people didn't get was why are we using the get host name? This was always I was always told that this was good programming practice in the sense that you should be able to know how to automate the process of getting the IP address of the server. That's what this function does here. It gets the host name. In theory, it gets the IP address. Now, of course, this usually causes a bit of trouble because if you're running it on Windows, it might not get the correct IP belonging to the subnet, and you can experiment that for yourself. Now, I didn't mention it in that video. That was because we weren't testing the connection. But this host, just as it is, of course, there are a few additions that I was going to make. So you can see that the variable here is using the module and the function from the socket module called getHostName. So this essentially will get the value or the IP address of the host or the server. Now, if you don't want this, you can easily just change or add the IP address here. In fact, I could add this comment right here. I could say host is equal to, and because it's a string and we want to keep it that way, I would check my IP address of the server. So IP config, let me just check that, and yes, it is 0.104. So 192.168.1.104, and that's how I would initialize that variable. But again, you can see what I was talking about when we talk about automation. It's always good to make your script as intelligent as possible. So that's why I use this function. So for those of you asking what it does and what parameters you can specify, specify. The parameters can furthermore be specified when you're talking about binding to the socket. So for example, this is commented and it's not active, so we can change the value in here and replace it with the IP. So 192.168.1.104, and remember to put it into quotation because it is of type string. You can convert it to integer, but we're already converting it for ourselves when the data is being transferred back and forth. All right, what was I doing here with the percentage sign and with the str? So essentially, str is to convert this into a string. All right, and the percentage allows you to convert certain data into different data types. So for example, if I wanted to convert it into a string, I would use the instead of using str, because then I would have to encapsulate it twice, and then it would be too much. I would use the percentage and the s command, and as you can see, the s will denote a string conversion. Okay, so that means we have converted this into a string. Now, for those of you who are a bit confused and you're asking whether you can encapsulate it as one whole data type, in Python, what you would do is you would use the wrapper command, which is the R command, which if you just hover over it right now, you can see that it doesn't really mean string, and I'll explain what this does. This means that this statement will not be printed in the form of one data type. So right now, when we had S here, it was printing it out as a string, but when we have the wrapper can be used to make this statement as unambiguous as possible, in the sense that it is not printed out in the traditional way of a string, which is also very, very useful, and we'll be looking at that later on. And then we are supposed to encode it and keep the data path as small as possible, because if we were to do this and not encode the data, the likelihood of us transferring this data, this would actually fail if we tried. So I'm going to do that. So it's really very simple. So the message is the message variable, and we want to encode this. So we use the encode function. So encode, and in brackets we specify the encoding type. So we can specify. You can see that you can specify UTF-8, but in this case you said ASCII. So let's keep it to ASCII. Now, when we're creating the client, I know we are stretching along a bit too far now. When creating the client, I'll show you how to decode this message, and I'll also show you a way of not using a loop once we've established connection. So let's get started now with the most important bit, which is creating the TCP client. Now the TCP client is really very simple, and nothing has changed or will come over in terms of client, in terms of functions. So there's no new functions that you should be looking for, but probably the only one would be the decode and encode. All right, so let's get started. So the first thing I want to do is I want to specify the Python version that we're using. So user bin and Python 3, sorry about that. So let's import the module. Now, again, a lot of you are saying why it didn't import everything. Again, I said we're going really, really slowly. We're going really, really gradually. We're building our skill set as we move along. So I'll show you how to import how to import every method or function from the entire module. It's really very simple. Sorry about this. Not module, socket. I typed out what I was thinking. All right, so import socket. Now we need to create the socket object, and we can just call this client socket, and that's going to be equal to socket.socket. And in here we would specify the IP protocol version, and then the transmission control. The TCP, or we would specify UDP, a connectionless connection, or one that uses a handshake, which is TCP, and that's what we're doing. All right, so we'll say socket.af inet, and we then say, socket .af. Actually, this is supposed to be socket.sockstream, actually, because yes, we have specified that. So that socket.sockstream. If we're using UDP, we would say dgram. That's what we'll be looking at in the next videos, and I'll probably make an advanced one with that. I was thinking of making a little chat application, and then since this is ethical hacking, it wouldn't be wise to create a GUI. But anyway, we'll be looking at all the frameworks and all that exciting stuff as we move along. All right, so again here. In terms of specifying the host, we can actually give it the variable. So this is going to be the server IP. Now, this is where now you would have to specify it every time, or you'd have to make sure that the client does know the IP address of the server. So in this case, we can also specify 192.168.1.104, or you guys can also do it the correct way, which is to get the host name, and then you specify the host when connecting to the port, which is the preferred way of doing it. So what I was talking about is if we say host here, and I'll comment one of these, we can say socket.getHostName. Oops, sorry about that. .getHostName, and then inside the parameters we don't need to specify anything. So if I comment this and we use the preferred way, let me just specify the port which is supposed to match. Sorry, that is 444. Yes, that's the correct one. So now when connecting now to the port, I would say client socket.connect, because we're using the connect function, and in here I would specify the host, which is the address, as you can see, and the port. Now I can specify it right now, so I can say 192.168.1.104, and any of these methods will work just fine. And then we can specify the port, or you can change the port here, as that's how Python is interpreted. Okay, so we specify the port. Now, the most important thing, and also something you guys pointed out, is how we're managing how data is being sent. So yes, we can essentially make sure that the data is coming in units or in a certain amount of bytes, meaning making sure that we will not accept any more data than what we need. So since we've encoded the message, we can finally say that the message should be sorry about that. Client socket should be less than receive. So I'm pretty sure we can say dot receive, and we specify the data, the buffer size as it's telling us here. So this will be, sorry, not 1023. So this is the maximum amount of data that we will allow to come through the port, okay? Or that we will allow being transmitted using the transmission control protocol. Now again, you can use the same unit factorization to increase. So you can say 2048 and so on and so forth. You get the idea of how data is sorted out. In addition, I will be making an illustration of how sockets work, because most of you pointed out that you could not understand, and I do agree that was my mistake. Apologies there. All right. So now, if we don't want to create a loop here, that's also something that is not very smart to do. What we can do is we can say, since we've received, we now need to decode the message, because remember the message is encoded in ASCII. To save time, because the decoding will take a while, depending on the amount of data. We can close the socket because we've already, client, I keep on using S because that's what we used to use as the object name. So client socket, and in here we would specify the fact that we are closing the socket, so close. And then we can finally decode, so we can print this out. We can say print, and we can say message.decode, and we know how to do that. That is ASCII, that is what we're decoding, and that should be the TCP client. Now, of course, I'll be commenting this and adding documentation before I upload it to GitHub so you guys can understand what's going on. Alright, so I'm currently on Windows, and the way we're going to test this is I have one of my virtual machines running, one that I could get set up really quickly, which is Ubuntu, so that's going to be our client. So what I'm going to do is I'm going to transfer the TCP client, the Python file onto this virtual machine, so let me just do that right now. There it is, TCP client, so I'm just going to drag it across, as that would be the easiest way of doing it. So I think I have Python 3 installed. It would be a real bummer if I didn't, sorry about that. For some reason my virtual machine. Alright, so we have it on the desktop, so let me just open up my terminal here, and desktop, let's list the files. Yeah, there we are. So Python 3, hopefully I have it installed. I should have, because I use this for web development. So TCP client, and let's hit enter to see if it works. And for some reason it is listening. That's weird. Did we already start the server? Or was it already running? Because I think I had it running when I was testing it. Anyway, don't worry. Let us try and run this again. We can run the server now in the terminal. So I'm going to run it here through Visual Studio Code. And yes, it has received it twice. So there's something wrong. So what I'm going to do is, let's stop this and let's change the data here just to see if it works. All right, so thank you for connecting to the server. This is an example of how sockets can be used. All right, so something, just we've added some more data there. It should be able to handle this. So let's see what we have here. This was just added a few moments ago. That's weird. All right, so let me just run this in the terminal. So yes, the server is running. That was really weird. Let me just see if this is working. We should be able to get it. All right, so we see it's working. That's how the message was transferred. I think I ran this before. Now when I was testing the bytes there, the amount of bytes that can be sent using, all right, so I get what happened. So I did perform the run. I ran it once, and I specified the host. Yeah, I was testing the port scanner. Sorry, but as I said, I was working on another script and I was testing the port scanner, and I was testing it on this client because this is the only virtual machine I have. So you can see that it was successful. We were able to get the message. Hello, thank you for connecting to the server. This is an example of how sockets can be used. Now, of course, this does not look very complicated, but we have, in essence, we have been able to send a message across. Now, again, a lot of you suggested that I create a chat application, and I was thinking about that, and you know what? I think I will have that as one of the next projects that we'll be working on. That'll really make it awesome, especially if it was an instant messenger type of chat. So now let's see if we got the message that was supposed to be displayed on the server, and yes, we did. We got received connection from 192.168.1.106, and you can see this is the correct syntax. Let me just make that a bit better. We can use that again, and let me just kill that session there. Let's run this in the terminal again. And that is waiting or listening for a connection. Let me run that again, and let's see how. Yes, so received a connection from 192.168.1.106. So that worked perfectly. And again, you feel free to customize how you want to specify the host or the server IP. And also, I'll be also tweaking this to give you extra options of automatically setting the server IP in the TCP client. So for those of you asking why there weren't any additional features like encryption added, as I said, this is a gradual process. We will be learning how to incorporate the most important modules from the Python standard library and how to create really awesome scripts. As I said, so you can consider these really good examples for you to learn how everything works with sockets. So that was how to create a TCP client and TCP server. Not really, awesome, mind-blowing stuff, but it's.
I think I kind of got it.
We're going to be looking at creating our very own tools and utilizing the Python programming language to essentially create various tools that can use to automate tasks, to automate various aspects of the penetration testing lifecycle. So without further ado, let's get started. Now, as you've probably read by the title of this video, we'll be looking at creating an Nmap scanner. Now, this is going to be part of a larger project. All right, so for this video, let's start off with creating a very simple Nmap scanner with Python 3. So my development environment for this entire project will be as follows. I'm currently running Kali Linux. All right, so you can test it out on any Linux distribution or on Windows if you want. Just make sure to install the Python Nmap module. All right, now we're going to also be using Python 3. All right, so as you can see, I'm using Visual Studio Code as my integrated development environment, and I have the Python extensions installed from the extensions manager right over here. I've set up my, if you can just take a look, we have set up my interpreter that is going to be used for the project. So make sure you set it as Python 3. All right, so I'm going to be discussing various methods and various Nmap methods, and I'll explain, hopefully I can explain what each and every one does. All right, so the program that we're going to create today is we're going to create a very, very simple program that will ask the user for an IP address that they want to scan. It'll then prompt them, it'll then ask them for to select a type of scan that they want to run. For example, we could have a SYN scan, a UDP scan, or a complete comprehensive scan that will include operating system fingerprinting, service fingerprinting, an aggressive scan, SYN scanning, and also using the default scripts that come with Nmap. All right, so to get the Python Nmap module installed, make sure you have pip, and for the appropriate version, make sure you have pip installed for Python 3. So let me just open up my terminal here, and I'll increase the font size here. Just give it a second. There we are. All right, so to install it, all you need to do is simply type in you simply need to type in pip3 install, and you have your Python Nmap, if I'm not mistaken. So just hit enter, and they should install the Python Nmap module. Just give it a few seconds to start collecting the details, and there you are. So I already have it installed, and you can see the latest version is Python Nmap version 0.6.1. All right, so we're pretty much good to go at this point. All right, so let me just go back into my development environment here, and the first thing we are going to do is we're going to need to import Nmap. So to do that, as you probably know, through the syntax of Python, is done by typing in import Nmap. All right, and that's as simple as that. So we've imported the Nmap module, and now we can use the various classes and methods that come within the module, which are extremely helpful. We're then going to create a variable called scanner, and this is going to be used to call the class, the Nmap port scanner class. So to do that, we simply type in Nmap, and we use the port scanner class right over here, and we can also just add the two brackets there. All right, so if you hover over the port scanner right over here, it should give you a bit more information about the class. So there you are. You can go ahead and inspect it if you've set up your development environment correctly. All right, so we have assigned the variable. We're using the variable to call. So whenever we use the variable, we are going to be extending the functionality of the port scanner or of the Nmap module, really, or the port scanner class. All right, so now we're going to prompt the user. We're just going to say welcome. And of course, as I said, this is going to be part of a larger program. So this is going to be one function. So when we're going to be compiling everything together, this is going to be one part of the entire larger program or script. And it'll be completely open source. And a lot of you guys can improve it if you want. You can fork this on GitHub and improve it in any way you feel is much better, or will increase the performance, the efficiency, etc. All right, so we're going to say welcome. This is a simple Nmap automation tool.
All right, so simple Nmap automation tool, and that's pretty much it for that line. We're now just going to add a divider here. So I'll just create a small little divider here that will just separate this from anything else that we're actually going to get started with. All right, so now we're going to prompt the user to enter the IP address that they want to scan. And to do this, we're going to be using, we'll assign it a variable, and since we're inputting the data, we can prompt them and then wait for the input, and I'll show you how to do that. So we're just going to create a variable called IP address, and that is going to be equals to the input, and we have the prompt there that's going to prompt the user to input. So we're going to say, please enter your, or we can just please enter the IP address you want to scan. All right, so you want to scan. All right, and we can just give it a nice little colon right over there, so we have great punctuation, and then we're going to print out, we're going to say, we're just going to make sure that the user has entered the IP correctly, so we're going to ask them if this is the correct IP, so we're going to say the IP you entered is, and since the value is already, we've already given IP address to the value, the user has already inputted it, we can simply just give it a nice little space here, and use the variable IP address there to display what the user entered. All right, and the type is going to be that of the variable itself, or the data that the user inputs. Of course, we're going to be sanitizing the input to make sure that that no other pieces of text are entered, because if the user enters any strings here, it will really not be helpful. All right, so now we can now create another variable here that is going to ask the user to select the type of scan they want to run. All right, but before we do that, let me just save this and make sure everything is working correctly. So I'm just going to run the Python file in the terminal, and for some reason my compiler here is not allowing me to actually execute this. Let me just make sure I have the correct Python version here. So let me use Python 3 like so, and let me just run this one more time. If it still gives me the error, let me just run it in my terminal here. All right, so cd desktop, and we're just going to run Python 3, and that's going to be scanner.py, and there we are. So welcome to the simple Nmap automation tool. Please enter the IP address you want to scan, 68.1.1. When it enter, and there we are. So that is working perfectly. It's going to even give you the IP that you entered, which is awesome. Now we can extend the functionality a little bit more. All right, so we're going to be calling the variable response. So this is going to be the response that the user gives when prompted or asked as to what scan they want to run. All right, and again, we're going to be prompting or waiting for the user input here. We're going to have a multi-line we're going to have a multi-line string, we're going to have a multi-line strings here. So we're going to essentially just make sure that this goes to a new line. So to the next line, so we're going to say, please enter the type of scan you want to run. So the type of scan, sorry about that. The type of scan you want to run, and we'll move on to the next line, and let me just tab this right over here. We can indent it so it matches that, and we're just going to say option 1 is going to be, let me just make sure that is correctly lined there. Sorry about that, let me just indent that correctly. All right, there we are. So we're going to say option 1 is going to be a synac scan. So synac scan, punctuate that correctly, and we're going to say option 2 is going to be, let's see, a UDP scan. Of course, we'll be increasing the functionality of this scanner, but for now, let's focus on very basic options that we can provide. Let's say we want to use now, we want to perform a comprehensive scan, and that can be denoted as follows, and you can also give the user a bit of an idea of what this scan will do exactly, but for that, that's fine. Now, we can also say, let me just get out of that indentation, we can now print this out and say, we can also make sure, we make sure that the user has selected the option correctly, so we can say selected we selected option, and we can just give it a nice little colon there, and again, we use the variable to which the value is assigned, like so. All right, now we can use our conditional statements to either run scans depending on the answer that, or depending on what the user wants to run in terms of a scan. So option 1 is a synac scan, option 2 is a UDP scan, and option 3 is a comprehensive scan. All right, so to do this, we get started with our if statement. So if, well, we don't need to get started with the equal sign. So we're going to say if response is equal to 1. All right, so that is the synac scan. Then I want you to do the following. All right, so we're going to say if response is equal to 1, we want to first of all print the Nmap version out. We then want to initialize the scanner or use the scanner variable to call the Nmap class so that we can essentially start the scan, and we can provide the arguments in regards to the amount of ports that you want to scan and the Nmap options or arguments that you need to provide in order to perform the synac scan. All right, so let me show you what we're going to do. So we are going to, let me just make sure that is indented correctly. All right, so we're going to say print. We're going to print out the Nmap version. So I'm just going to add some text here. We're going to say Nmap version is as follows. We'll give it a nice little space here, and we're going to say scanner.nmap. So we're using the scanner variable, and now we're calling the additional functionality. So scanner.nmap version, and we can then use the parentheses right over there. We don't need to specify anything else. All right, so that's going to print out the Nmap version, and now we can actually get started with scanning. So we're going to say scanner.scan, and in here we provide the IP address. If you remember in my Python 2 video, we actually specified the IP address within the script, which is not cool. It's much better if a user can input the IP address that they want to scan. All right, so we're going to say IP address, the variable IP address, which we assigned earlier, which is not like that, it is like so. And now we're going to specify the range of ports. So for a default scan, we're just going to scan the ports from 1 to 1024, or you can run even the entire spectrum of ports if that's what you want. And of course, we'll be customizing it. All right, so now we can then specify the arguments. So we want to verbose the output, and we're going to perform a simple synac scan. So that is denoted by SS. So those are the arguments. So the scan requires all of these. It's very simple to understand what's going on here. Just like if you would run a simple Nmap scan in your terminal, you first provide the Nmap. You type in Nmap. You then provide the IP address, the port, and the type of scan you want to run. Now, of course, if you don't specify the port, it's going to scan the 1,000 of the most popular ports which you can do. But it's always good to have that in place in case you want to customize. In case you want to customize the range or the types of ports you want to scan. All right, so we have essentially started the scan. Now we need to print out the scan info. All right, so the scan info will display various bits of information, like for example TCP, the services, and the method. So if it's a connect method, it will display that. So to do that, we simply type in print. We're printing it out. So we're going to say print, and we're going to say scanner.scan info, and it'll give you this right over here if you have IntelliSense enabled in your integrated development environment. All right, so we're just displaying the scan info, and now we need to print. We now need to display whether or not the IP address is up or down. When I say up or down, whether it's active, it's connected to the internet, it's reachable or it's unreachable. So to do this, we're going to say print, and we're going to be making a use of the state method that comes with Nmap. So I'll show you how to use it. So we're just going to put in some text. We're going to say IP status, so just so the user understands what's going on, and we'll leave a nice little space there. And we're going to call scanner. We're going to say scanner, and in your square brackets, we're going to give the IP address variable. So IP address. Let me just make sure that is spelled out correctly. So IP address and IP address.state, and that is going to essentially show if the IP address is up or down, so the user knows whether it's online or offline. All right, we have our parentheses here, and now we need to actually print all the protocols. Now, the protocols essentially just prints out what protocol you're scanning for, whether it's TCP or UDP. That's essentially what you're going to be printing out. And of course, you can edit the order in which you want all of these results displayed. This is totally up to you. All right, so we're going to say print. Well, we have entered the scan information. Now, yeah, if we're talking, we've entered the state, yeah, we probably now should display what protocol we're scanning for. So what I'm going to do is I'm going to open the brackets here, and we're going to say scanner. Scanner, of course, the IP address. It's important to always specify the value of the IP address here. IP address in square brackets, and this is all protocols. All right, all protocols, and open the brackets right over here, and we'll go down down over here. And now we need to essentially display the open ports. That's probably the most important bit of information here. Now, to do this, we use the keys method. All right, now the keys method will essentially return all the active ports or all the ports that are reachable within the specified range. All right, so to do that, the syntax is extremely simple to understand. All we need to do is set type in print. So because we're displaying it, and we can say the open ports are going to be, and we'll give it a space, and we'll say scanner, and of course we specify the IP address here. So IP address, and that is going to be, we need to specify the type of protocol, so TCP in also square brackets, and then the TCP dot keys. All right, so the keys method allows you to display, as I mentioned earlier, or will actually return all the active ports available within the specified range. All right, so that is how to use that. Now, we have currently finished one of these conditional statements, and of course we have to use the elif statement here. But before we do that, let's actually test the functionality, and we'll test the first option that we've created for, if that is a syntax scan. All right, so let me just run this in my terminal. I'll actually keep that open now so we can have it on standby. Desktop. All right, so Python 3, and we're running the scanner.py. All right, so please enter the IP address you want to scan. I'm going to try my router, because it probably has about 3 ports open, 192.168.1.1, and it's going to ask us to enter the type of scan we want to run. And of course, we see our first error here. We haven't actually switched to the next line right over here. So before we actually do that, let me actually add that piece of code right over here so that we actually move on to the next line. All right, so we'll just use the end command right over here. Oops, that's my bad. And that is going to be the end command. And there we are. So that goes on to a new line, and we'll just break this right over here, and we'll start that one more time. 1.1.1 is going to ask us for IP address, for the type of scan that we want to run. Since we've indicated for option 1, I'm going to hit 1. So it's going to tell us you've selected option 1. It's going to print out the Nmap version. It's then going to print out the scan info, which you can remove if you don't need it. The IP status is up. You can see right over here. The protocol we'll be using is TCP. The current open ports are 22, 23, and 80. All right, so it's displaying the information that we wanted. Now, many of you will say, well, this isn't really information that is displayed or formatted correctly, and I totally understand and agree. We are going to be looking at how to get only the information we want. For example, we don't need it to display all of this right over here. We can essentially sort it out so it displays it in a much better way, or a much understandable way, similar to what we have here with the IP status. All right, now, if I was to run the script one more time, and I enter an IP address on my local area network that does not actually exist or is not online, it should be able to tell us that it is offline. All right, so there we are. You can see IP status is down, and of course we're going to get an error here given by the fact that it's not currently online, which we'll be sorting out as we move along with this project. All right, so that is the first option catered for. Now we use the elif statement here, and we're going to say if we're going to provide another varied conditional statements here in case the user enters another option, which is option 2 next, and we can pretty much copy this, except this is going to be for the UDP scan. So we need to change a bit of the syntax to actually match that of a UDP, to actually make it work for UDP, and I'll show you what we need to change exactly. Now I do not want to damage the indentation, so I'm just going to copy this right over here, and because we do not need to type it out, we do not need to type everything out. So what we need to edit is we can leave the port range as it is. We don't need to change anything there. Instead of verbose output, we can change that into SCU, so we're scanning for UDP ports. Scan info is fine, IP status is also fine, the protocols are fine. We only need to change the TCP into UDP right over here, so it displays the UDP ports that are currently active or online. All right, and if we save this and run, we actually should see that this should be able to scan UDP ports. So I'm going to run it. I'm going to enter one of my Windows computers, 192.168.1.102. Going to hit enter. I'm going to hit 2 for UDP scan. You've selected option 2. The Nmap version is version 7.70. And we're just going to give that a few seconds to scan for all the UDP ports available. It should return the port 137 right over here. Excellent. So we know it does work, and it's telling us the IP status is up, UDP, and the open ports are port 137. We'll be looking at how to get rid of all of this information right over here. But for now, do not worry about any of that. Just focus on the functionality and the fact that it is returning the information that we want. All right. So we have our final version here that we need to our final option, that we need to cater for, and that is going to be for the comprehensive scan, which is going to be like a complete scan. All right, so I'm just going to paste in what we copied earlier, and we'll edit it appropriately. In this case, we are going to stick with TCP, and that is a comprehensive scan. So our comprehensive scan is going to be, of course, verbose output. We're going to use the syn scan. So again, I'll just make sure that is there one more time. SV for service fingerprinting or service enumeration, SC for the default scripts, and an aggressive scan and operating system detection. So quite comprehensive in terms of what it does. You can edit the amount of ports you want to scan for. You can change that right over here, and we'll be adding that functionality so the user can enter the amount of ports that they want to scan for. All right, and this should work now for the comprehensive scan. We're not going to test it because I'm pretty sure it is going to work. Now we can print in our last else statement here in case anyone enters anything funny or anything over 4, so that we can actually just exit the program. So we're just going to make it a very simple exit right over here. So if sorry, what am I doing? Else. Well, we can just say, we can also use the elif instead of else. So elif response is equal to, well, we can actually say greater than or equal to 4. So if it's anything like 4 or greater than 4 or 4 really, then it should print out this. Now, of course, I have forgotten to include the colon here, which would have caused a lot of issues. And we'll just go down right over here, and we're just going to say print, and we're just going to say please enter a valid option. Okay, and this is pretty much what we're going to be looking at in this video, or what I wanted to cover in this video. We can, of course, extend the functionality a little bit more to make it so that once the user has got the results, it reloops the program if the user so wishes to. But for now, let's just stick to this as the closure to this program or to this simple module that we've worked on in this episode. So I'm just going to save this, and let's test if this script actually works or is functional, and we can actually use it for getting results. All right, so what I'm going to do is I'm just going to drag this right over here so we can see everything that's being displayed, and we're going to run Python 3, and there we are, Python 3 scanner.py, and we're going to enter the IP address. So I'm just going to run a comprehensive scan, 0.1.102 on my Windows operating system. There we are, comprehensive scan. We're going to hit option 3, and it tells us you have selected option 3. The Nmap version is Nmap version 7.70, and of course, given that this is a comprehensive scan, it's going to take a while, so I'm just going to wait for this to complete, and I'll get back to you when that's done. All right, the scan is completed, and it pretty much gave us the information we were expecting in terms of what we wanted it to display. So display the Nmap version, the scan information, the status of the IP address, the protocol that we were using, and the open ports. Now, given that this is a comprehensive scan, it should have displayed more like the operating system that was detected, but of course we haven't added that functionality yet.
I think I kind of understand, I'm kind of following, but it feels that it was thrown randomly here. Like out of nowhere, it starts talking about this library. It's a little bit random. But
And in
as
this
you can
video,
understand,
we are going to be taking
you can understand all the videos so far.
And in this video, we're going to be taking a look at how to create a banner grabber with Python 3. All right, so without any further ado, let's get started. For those of you asking what I'm currently using as my IDE, I currently use a Gitpod, which is a GitHub extension or an application that allows you to edit your code on GitHub using an instance of Visual Studio Code, but adapted to that, so you can actually work on, you can actually work on your code through your browser, and your code is automatically saved to your GitHub repository. So it's a great tool. You can check it out. So the first thing I want to do is I want to lay out the logic to sort of explain what's happening behind the scenes so that you can understand it. And then what we'll do is we'll make the code a bit more organized and efficient. All right. So the first thing we want to do is we want to import the socket library. All right. So socket, and that's pretty much given that we're going to be working with sockets. So what we can do now is sort of understand the logic of the script. So we are going to require the user to enter an IP address and a port, which is always better instead of specifying it manually through the script. So we are going to need to have that done. Secondly, we need to utilize some of the socket libraries or some of the socket methods or functions to actually connect to that port, and then the data that we receive back is going to be the banner. So that is in essence what's happening in the background, right, or the logic of the script. So what we're going to do is we're going to start with the default convention. So we're going to call upon the socket module from the socket class. So again, sorry, socket. There we are. And if we just highlight over it, you can see the module socket from the module class. So from the socket from the socket class. So now that we've initialized that, we can now use S to call upon various other functions or methods within the socket class. So let's get started by first laying out the logic here. And again, we're going to prompt the user to enter the IP address. So we're going to use the variable IP, and we're going to say input, and we're going to say please enter your. We can say please enter the IP, right? And we can use that. And then for the port, we need to convert this. We need to convert this into a string so that when we pass it, we can actually connect through it. But we can actually connect through it directly or convert it back into an integer. So we can just say input, and we can say please enter the port. And very, very simple there. And now we can say, all right, we're ready to connect. So we'll call upon the connect. We'll call upon the connect module here. So there we are. So that's the connect function. And we will now need to pass the parameters, which are going to be the variables that we just got here. And of course, the user has inputted the values. It's going to be IP, and it's going to be port, right? So those are the two parameters that will then be used to, for the connection. And now we want to receive the data. So what we can do to save time and make everything simple is we can say print out what we receive immediately, and we can limit it to 1024 bytes. So I'm going to say s.receive. So we're going to call upon the receive module here. So again, you can highlight over it, and of course, it's the receive function. And of course, within the receive function, the parameters we need to specify are the size, the maximum size of, or the maximum amount of data that we should receive back. And of course, we're going to print that out. So we can save this now, and let me try and run this in my terminal, or let me try and run it locally so that we can actually test a banner here. So I'm just going to download this script, and we'll go and let's save this here, and let me just open up a terminal, and there we are. Just go into my downloads folder here, and we have the banner grabber script. So chmod +x and banner grabber, and we can say Python 3 banner grabber, and hit enter. It's going to ask us to prompt. It's going to prompt us to. It's going to prompt us and ask us about do I actually enter the IP. So I'm going to enter my router's IP address, and I know I have SSH running on my router, so I'm going to just specify the IP address here. And the port I want to specify is the SSH port. So let's see what banner we're able to get from the SSH port. I'm going to enter, and you can see we got an error here. So the error is telling us that an integer is required, and we got a string, and that's because we need to actually convert this. So what I'm going to do is I'm going to say, let's convert this into a string here. Or we can actually enter the port with single quotes, but let me just convert all of this into a string. And we then furthermore need to convert it back into an integer here, which is pretty much necessary. So I'm going to convert this back into an integer. So let me just add the last bracket here, and we can save this. And what we can do is let me just remove the previous script here, or I should have just edited it. In any case, let me just download the fresh script here, and I'm going to hit save. And of course, I can run it through Gitpod, but again, I'm running this locally, so it'd be much better to have it this way. So what we'll do is let's just run that one more time. And then we will run the script here, and we enter the IP address 0.1, and we'll hit port 22 and hit enter. And as you can see, it tells us we're running SSH 2 or 2.0, and this is it's running drop bear SSH here, or drop bear service, and you get the service version number, which is 2012.55. So again, it's quite an outdated SSH server. Or SSH server program running, and again, now this is where we can sort of start integrating these various banners, in a list. Also, we can sort of collate a list of vulnerable banners or vulnerable services and their banners into a text document or into a list, and then we can create our vulnerability scanner. So, for example, if the drop bear SSH version 2.0 was vulnerable to a particular exploit, we can add this to a list, and then we can scan our entire network, and any computer, any system that is running that particular version will be flagged. But we'll be covering that in the vulnerability analysis section. So the next step now is to sort of make the script a little bit more functional and sort of organize it better, right? So, and many of you actually asked me to start including functions more, right? So I'm going to just remove the script here, and what we can do now is let's get rid of all of this here, and we'll rewrite the script with functions. All right, so what I'm going to do now, let me just create the main function, and the main function, I'm not going to pass any parameters through here. So again, the logic is very simple. We're just going to prompt within the main function, we're going to prompt the user to enter the IP and the port, right? So we're going to say IP is going to be equal to, and then of course we specify we want the user to input this. We say please enter the IP like so, and then we say port is going to be equal to, we're converting this into a string, and then the input here is going to be, we're just going to say, we'll give an input message, please enter the port here, like so, very, very simple. And then we now need to create our banner grabbing function. So let's just create it up here. So I'm going to say def, we'll just call it banner. Yeah, let's just call it banner, and we want to pass the parameters we want to pass are going to be IP and port, of course, because we want to use them here. So I'm just going to hit enter here, and we can get started. So now the function or the functionality pretty much remains the same. So we're going to initialize the socket module. So socket from the socket class. So socket, there we are. And now we can say socket.connect or s.connect, and we then pass in the variables here. and we'll say IP and port, and we need to convert this into an integer because we are passing the values entered by the users from the main function. So I will just enter this here, and let us close those brackets over here. All right, excellent. So now we can actually print this. So again, we just say print, and we just say socket.receive, and we will limit this to 1024 bytes, and we can hit save. However, we still need to call, we need to make sure we call the banner function within the main function, and of course we need to also specify the main function, which is really easy to do, and I'll be covering that specific syntax as we move along. So we can just say banner, we give the function name, and then of course the parameters in this case is going to be IP and port that we want to pass through, and that should initialize that function, because the main function is usually executed first. So we can say main here, and that's going to execute the main function, and then the main function is going to call upon the banner function, which will then again give us the banner grabbing functionality that we're looking for. All right, so that is quite simple. So let us save this script now, and we can actually download this, and there we are, and we'll just wait for it to download and save file, and we can now move forward. All right, excellent. So let me just clear this. Let me just clear the terminal here. And we want to give it executable permissions. And once we launch the script, again, we're prompted by the text here. So please enter your IP. And you can test this on a variety of hosts. I'm just using my router because it does have a familiar banner running on, or it does have a familiar banner running on that particular SSH service, one that you guys can actually see works. So again, I'm just going to port 22. I'm going to enter, and we're going to see that the name socket, and yeah, that is because we did not import socket. Sorry about that. So import socket. There we are. That's the importance of libraries here. And you know what? We can just edit this from the. We can just do it through Nano. So there we are. We'll just hit import socket. There we are, import socket, and we can just hit Control O, and we're good to go. All right, so let's run the script one more time. 0.1.1, 22, hit enter, and there we are. We can see it's running SSH version 2.0 drop there. Now, this is where, when it comes down to improving the script, and I'll show you why in a second, you might want to start using exception handling. For scripts in which you have functionality, or you are probing targets for data, and you might not be sure as to what data you will be receiving, and you want to make sure you can handle your exceptions really, really well. So again, if I say, let me just run the script one more time, 3.1.1, and I say maybe port 1, for example, which of course no service is running on port 1, and I enter here, you can see that it's going to tell us the connection was refused. So we can use exception handling, and this is what I want you guys to do. You can find the script on GitHub, and I want you to implement, try and accept, for example, so that any other data than the data we're looking for is rejected completely, and we get a user-specific error, like we could not retrieve a banner, or we could not connect to that particular port, right? So again, this tells us that the connection refused. And again, we can try other services. So I'm not sure if I have port 80 running. I think I do. Let's actually try 192.168.1.1, port 80, hit enter, and let's see what happens here. And yeah, we will be waiting for this to give us a response here. If it doesn't give a response, we also might want to implement the default timeout functionality here. So again, we can just terminate this, and we can say, if it doesn't give us a response within, so we can say s.set, we can say set the timeout here, and we can say, let's give this 5 seconds. So if we don't get a response within 5 seconds, we want you to actually terminate the script here. So we can do that. Now, I'm sure most of you actually realize this. So what I'm going to do now is, if we try and take a look at the banner, we can see that we can actually clear this out quite a bit. And I wanted to introduce one of these string stripping functionality here. So what I'm going to do is I'm just going to hit bannergrabber.py here, and now where we actually print out the data that we receive, we can actually try and play around with the way the data or the banner is displayed to the user. So I can say, for example, Python 3, and we can say bannergrabber and hit enter, and I'll just use port 22, and as you can see, we have some text here that again we might not want, and we simply want to get the banner itself. So for example, if I wanted to get rid of this b here, I can do it by using the strip or the string strip method here. So again, very, very simple to implement. So let us actually do this. Sorry, I wanted to use Nano here. So we go to print, and right over here is where we start implementing the functionality. So the first thing we want to do is we need to make sure that we're dealing with a string here. So we want to convert this into a string. So we're going to say string, and we're going to say s.receive, and we're going to limit this to again 1024, and you can play around with that as much as you want. And then we are going to say we want to strip this, or we want to strip the data you receive, and we want to get rid of this anything that has this b over here, which I know is quite vague, and it's prone to give us errors, especially if the banner does have a b here. But again, we've specified the apostrophe, and we can sort of, once we actually close this, and we can actually test it out now. So if you take a look at the previous result, you can see we have this b here, and now if we run the script 192.168.1.1 and 22, hit enter, you can see it got rid of that b here, and we now have the banner itself. So again, that's just an example of how to use the string strip method here if you want to actually clean out your output or the data you receive, and you want to print it out in a more convenient and really good looking format. So that's pretty much all that I wanted to cover in regards to the banner grabber script. In this particular video, we are going to be taking a look at creating a port scanner, a very basic port scanner. And I'm going to be using Gitport, which is a fantastic IDE that you can sort of use on GitHub. So again, it's a one-click online IDE for GitHub, and I already have my instance set up here. So I can essentially work on multiple files, and they get saved directly onto my GitHub here. And the link to this GitHub repository where I'll be storing all of these pentesting tools will be in the description section, so you can check it out for yourself. So just a few other bits of information. Our target website today will be hackthisite.org, and we'll be using the IP address to actually perform our scans. So let's get started. So I already have mine set up in my workspace on Gitport here, and I'll create a new file, and I'll call it, we'll just call it port scanner. And we'll be working with sockets. So if you haven't learned about sockets in Python 3, you can definitely watch our previous videos on that, and you can see immediately we're able to get started here. So we'll just close this up, and we will set up our environment user bin and Python 3, and we can actually get started now. All right, so I'll hit save here, and we can actually get started. So our main objective is to create a port scanner that scans an IP and a particular port and checks to see if it's open, right? So now that we're interacting with sockets, or we want to actually utilize networking in Python 3, we need to import the socket library. So I'm going to say import socket. We don't need everything, so we can just import this. We can just say import socket, and then we need to start creating. We're going to say s is going to be that's our variable. So we're then going to call upon the module we want to use. So socket.socket, and this is the class itself. So the socket class, and then we start saying the methods here. So socket, we're going to call upon the AF inet, which is specifying that I'm working with IPv4, and then we're going to say socket, and we're specifying the connection type now, which I've already explained before. So socket, also sock stream. Or stream, sorry, and it's a stream here, and you can essentially just highlight here. So we have the module socket, the class here, and then of course we call upon AFINet, which we're essentially using to specify the type of connection, which is IPv4, the protocol, and then sockstream specifies the type of connection. So if it's sockstream, it means it's TCP. That means there is a handshake going on. If you want UDP, you can also specify that as well. Again, you can refer back to our socket video where we explain all of this. So let us first set up a host that we can actually use to scan. So I'm going to say host is going to be equal to, and we'll just say host is going to be equal to, and we're going to get the IP for. We can just say ping hack this site.org, and we'll hit enter, and we just get the IP here. And of course, I'm guessing we'll have a SSL or HTTPS port open. So I'm going to say port is going to be equal to, we'll just say port 443, for example, which I know is going to be open, and we're going to be using this to test it. You can also test this script locally, which I'll also do just to show you that it does work. So now that we have all our basic components here, we can create a function, and this function, the responsibility of this function is to, of course, perform the actual scanning. So we're going to say def port, we're going to say port scanner. That's going to be the name of this particular function, and the variable we're going to be passing, or the value here, is going to be the value of port, and we're going to say if. We're going to use an if statement just to actually perform our scan. So we can say if s .connect, which is socket.connect. We can say if it returns an error code. So again, if we use connect x underscore ex, and we just hover over it, you can see this is like connect address. However, it returns an error code, which means it will essentially terminate, and we can get our results, and this will tell us if the port is closed, right? So instead of giving us an exception or raising an exception and then performing something else, we can just say if this is the case, and then of course we have to pass in the values here. So we're going to say host and port. We then say print the following. So we're going to say print, say the port is closed, right? Very, very simple. And then we say else. This is of course if it does not give us an error code, that means the port is open. So we're going to say print. So we're going to say the port is open. The port is open, right? So we can hit save, and now we actually need to call upon this function. I'm not going to create a main function just because I want to keep it really simple. So we're going to say port scanner, and I'm going to again pass the variable port here. So I'm going to hit save. I'm going to call that function, and we can right click. And this is the great thing about Gitport, so you can actually execute our code, and immediately we're told that the port is open. So let's see if they have an SSH port running here. I'm going to hit save, and of course we're just going to run this in the terminal one more time. It tells us that the port is closed. Let's see if they have port 80 open, and we'll run this one more time. And the port is open as well. So really, really cool stuff here. Let's see if they have FTP open, and we'll just run this one more time. Let's see if we can actually run this. For some reason, did I save the script? Let me just terminate this one more time here. Run that file in the terminal, and we'll wait for this to scan. So you can see that it takes quite a while for some scans, and we can improve the speed of this script by essentially setting a default timeout, and we get that functionality with the socket library or the socket module. So what we can do is, let me just terminate this one more time, and what I'll do is I'll download this script onto my computer here, and I'll just save it. So I'll say save here, and that's in my downloads folder. So let me just open up a new terminal here. So we'll go to cd downloads and hit enter. So chmod plus x, and we'll say port scanner, right? So now if I execute it, so I can say Python 3 port scanner and hit enter. It's going to, of course, we need to specify, we need to change the code a little bit here. So before we do that, let me just clear this out. Nano, and we will say port scanner, and let's change this to maybe my router IP address, and let's check if we have the SSH port open. Let's say 1.1.1, and we'll change this to port 22. Hit enter, and we'll again repeat the same thing, and the port is open, which is excellent. And now let us try and let's try another port here. Let's say FTP. So we can hit Control O, X, and get out of here. Run this one more time. For some reason, there we are. The port is closed. So with scanning web servers, it's going to take a bit of time, but I'll show you how to improve the speed shortly. So there are a few issues with this particular script. One of them is that we need to keep on going into the script to specify the IP and the port. So we should definitely implement some user input here just to make it a whole lot better. So what I'll do is I'll remove this script now, and we'll download it once we've made changes to the new one. So the logic is perfectly fine here. However, we do need to change a few things in regards to the host and the port variable, and we need to get some user input, right? So what we'll do for the host variable in Python 3, we need to specify the input. So that is denoted by input. And for the host, we can take it as a string. So we can say we then prompt the user to enter value. So we can say please enter. We can say please enter the IP you want to scan, right? And they're going to enter that. And for the port, we need to make sure that this is in the form of an integer, because that's the most important. We're going to be passing it through this particular function here. So to do that, we say int, and we're going to say input within this brackets here. Then again, we just give the user some text. We say please enter the port you want to scan. So let's just get rid of that port you want to scan, and we'll hit enter. Just to save it like so, and now we can actually make it the script a lot faster by setting the default timeout period. So again, this will be the period in which it will perform a scan, and if it does not get a response, it will return the value in this case. Again, once we're passing it, once we actually perform, we take it through the port scanner function. Again, we can set whatever value we want, and of course, this might not be the best thing to do because some ports may take a longer time to actually give us a response. So what we need to do is we can say s.set default. We can say set default timeout. We can set the timeout here. And we'll set the timeout to maybe, let's say, 5 seconds, right? So we can set the default timeout to 5 seconds here. Let's save. All right. And now, since we'll be prompted with the actual input for this particular user, so we can go back in here and we just copy this IP one more time, and we will run the script again. So we'll say now you can see it tells us right over here. We just increase the font size. You can see that please enter the IP we want to scan, and we can simply paste in the IP here. So we can say paste, and we hit enter, and the port we want to scan is port 443. Hit enter, so the port's open. So again, we can try this one more time, and we'll just paste in the IP there. And we can try this for port 21. And since we specified it to 5 seconds, now if it does, there we are. You can see after 5 seconds we get the response even faster. Now you can set this as long as you want, and you can also set up some logic to actually get the user to input the default or the timeout options that they're interested in, but that would really defeat the purpose here. So again, we can download this script and run it on our local network just to see how that goes. Let's see if it does work at all. So let's go to our downloads here. Yeah, we go to downloads, and again, let us just make sure we can just expand this a little bit here, and we'll clear this out.
I think I kind of understand everything there, but a little bit random, but yeah. Build a full stack JavaScript app that is functionally similar to this. So those are big projects. Since all reliable stock price APIs require an API key with boot to work well, use this link to get up to date stock price information without needing to sign up for your own key. So I need to build something like this using this link. Working on this project will involve you writing your code using one of the following methods. So I guess it's pretty similar to the backend API projects. Probably. I think I understand, at least I have a framework in the back of my mind of the steps that are necessary to build the full website, I think. I'm probably gonna have to research a lot each step, or because there are a lot of things that I forgot already. But at least the framework, I have it on my mind about how to build a server, the client, how they connect with each other. I think it's a lot. Everything's a lot more clear in my mind than when I started. Now I understand, I think, how everything connects and how things work a lot better. Set node in to tasks without quotes and set DB to your MongoDB connection string. Complete the project in routes API.js or by creating a header controller. You will add any security features to server.js. So this is the helmet stuff. So the way I would go, I'm not gonna do this, I think, but the way I would go about doing it is first create the HTML, CSS. That seems to be very basic. Then a server file, do the helmet stuff. Then make API calls, make the app.get or app.post, depending on which link I want some functions should be at. And then depending on which function I want, creating another file and calling that function inside of the calls, the getter and post requests. Only one leg per IP should be accepted. You will have to save IP addresses. It is important to remain compliant with data privacy laws such as the General Data Protection Regulation. One option is to get permission to save the user's data, but it is much simpler to anonymize it. For this challenge, remember to anonymize IP addresses before saving them to the database. If you need ideas on how to do this, you may choose to hash the data, truncate it, or set part of the IP address. Oh yeah, I will also have to do the Mongo database stuff. which you have to create a database table and then connect to the server.js file. And I don't remember really well how to build a mongoose object or a class, but maybe it's not necessary for this project. Yeah, I think I will take a break now. I'm not really sure if I'm gonna do these challenges. I'm gonna look at the solution. If I do them, I'm gonna do them by following the solution from other people. But I'm not even sure if I'm gonna do that because it will probably require me to, well, not probably, it will require me to enter a Mongo database. And I'm not sure if I wanna do that on stream. So take a break and I will see. Maybe I would do these challenges. Maybe I'll go directly to the machine learning section. And depending on, I'm gonna watch the videos of the solutions off stream. And then I will decide which one I'm gonna do. And then I'll probably come back later on today. Keep going. So see you.